All right, now these are pages 3 and 4. For this one, we have an electron, which has a position function given to us here in terms of meters and seconds. So the first part says find the average rate of change of the position. So when we see that, we're thinking change in position. That's going to be the position at 3 minus the position at 1. And because it's an average rate, we're going to divide by the amount of time it took to do that. Okay. So if I put 3 in here, I get 27 plus 18 plus 30. So 27 plus 18 plus 30 gives us 75. Minus, and if I put 1 in, I get 1 plus 2 plus 10, which is 13. And so I get 62 divided by 2, that's 31. Now the change in position is meters. The change in time is seconds. So this is meters per second. 31 meters per second is our average rate of change of position. Another name for this is our average velocity. So if they had asked for average velocity, we would have done exactly the same thing. Now B wants to know what's the velocity at 2 seconds. So we're going to take the derivative of our position function that gives us velocity. That's 3t squared plus 4t plus 10. Now if I put 2 into that, I'm going to get 3 times 2 squared plus 4 times 2 plus 10. This is 12 plus 8, 20 plus 3. That gives us 30 meters per second. That's our velocity right at 2 seconds. Okay. If we were asked what direction are we going, we'd be going to the right or the positive direction. And what speed? 30 meters per second. Is the electron speeding up or slowing down at 2? So this doesn't tell us enough. It tells us something, but what we need to do is find acceleration. So we take the derivative of velocity. That gives us an acceleration equation, which will be 6t plus 4. Then we do the acceleration at 2, which is 12 plus 4, or 16 meters per second squared. Okay. Now, we have a positive velocity. We have a positive acceleration. So we are speeding up because velocity at 2 and acceleration at 2 have the same sign. So then D says, can we find the average acceleration from 1 to 3? So average acceleration is the same as the average rate of change of velocity. So this is similar to part A. What we'd want to do is we'd want to go velocity at 3 minus velocity at 1 over 3 minus 1. All right, so if I put 3 into the velocity equation, I get 3 times 3 squared is 27, plus 12, 39, plus 10 is 49. If I put 1 into the velocity equation, I get 17. So I end up with 32 over 2, which is 16 meters per second squared. That's my average acceleration between 1 and 3. Okay, and that's, again, understanding, that the average rate of change of one thing can be the average of another thing. That's an important connection. Chapter 4, we're going to learn a new way to do average value that might help you. But for right now, I want you to understand this connection here in A and D. All right, the number 9 says, can we find the equation of a tangent line to this function when x is there? So in order to do that, we have to have a point, and we have to have a slope. So hopefully by now that's second nature. They gave us the x value, that's pi over 6. So I need to put pi over 6 into this equation, find out what the y value is. So if I put pi over 6 in here, I get 4 times cosine of 2 times pi over 6. 2 pi over 6 is the same as pi over 3. All right, so now I think cosine of pi over 3, that's cosine of 60. The side that's right next to 60, if I think about my 60 degree, 30, 60, 90, goes like this. And the adjacent side is 1, the hypotenuse is 2. So cosine of pi over 3 is 1/2. So this is going to be 4 times 1/2, which is 2. There's my y value. Okay. Now, in order to find the slope, I need the derivative. So I'm going to take the derivative of this. It's going to be 4 times the derivative of cosine, which is negative sine. So I'll put a negative right there. Keep the 2x the same, times the derivative of 2x, which is 2. So in other words, it's going to be negative 8 sine 2x. Okay. Now I want to find the derivative at pi over 6. which means it'll be negative 8 times the sine of 2 times pi over 6, or that pi over 3 again, right? Pi over 3 is 60 degrees. Sine, opposite over adjacent, now is square root of 3 over 2. So this is negative 8 times square root of 3 over 2, which is a negative 4 square roots of 3. That's our slope. So even though this is all weird looking, this is our value. So we're going to go y minus y equals slope times x minus x. A couple different irrational numbers in there, but that is our equation. And again, the process is exactly the same. Find the function value, find the derivative at the point, put it all together, right? Same process we've done lots of times. Number 10 wants us to find the derivative here, but this is implicit, so we're going to have to follow implicit rules on this. So first things first, you got to see that that's a product rule. Derivative of 2x squared is 4x. Leave the y squared alone. Plus, now leave 2x squared alone, times the derivative of y squared, which is 2y times dy dx. So there's our product rule with the implicit part. Derivative of 2x is 2. Derivative of negative 9y is negative 9 dy dx. Okay. So now what I want to do is I want dy dx is to one side, I want everything else to the other. It does not matter which side is which. I think this looks a little more complicated to move, so I'm just going to slide this guy over. So he's coming this way, and these two are going that way. So if I simplify this, this is going to be 4x squared y dy dx plus 9 dy dx equals negative 2 minus 4xy squared, and those could be flipped around. Now if we pull that dy dx off, I've got 4x squared y plus 9 equals this side over here, and then if I divide by that, dy dx is negative 2 minus 4xy squared over 4x squared y plus 9. And again, if you move dy dx's to the other side, then you have these exact same terms. You just have positive, positive, negative, negative, and that's okay. That would be totally fine too. And now 11 wants us to find the equation of a tangent line to 1, 4. So we already have the point, 1, 4, but we need a derivative, and specifically we need the slope at that point. So let's go ahead and find the derivative of this. We'll make our first pass through. Derivative of 3x squared is 6x. Derivative of y squared is 2y times dy dx. Derivative of 1 is 0. This is going to be a product rule. I'm going to go 5x is 1, y is the other. Derivative of 5x is 5. Keep y the same. Plus 5x times dy dx. Now, instead of getting dy dx by itself, which you're totally allowed to do, and then put your point in, I like to put the point in now. I like to just go ahead and make x equal 1 and y equal 4 right now, and then solve for dy dx like it's a variable. So if I put 1 in for x, I'm going to get 6 plus 2 times 4, that's 8 dy dx, equals 5 times 4, 20, plus 5 times 1 times dx, which is 5 dy dx. Okay. And I like doing it that way because now I think it's pretty easy. If we were solving this like a regular equation, we'd subtract 5 dy dx's from both sides, treating it just like a variable. You'd subtract 6 from both sides. We'd end up with 3 dy dx equals 14, and then divide by 3. Here's our derivative at that point, 14/3. That's our slope. So once we have that, y minus y equals slope times x minus x. And there's our answer. There's pages 3 and 4.